Geometry 2, force and motion in 2 dimensions. Today we're going to learn about inclined planes. So, inclined planes. With pulleys, what we did was we bent the axis along the string. With inclined planes, we're going to keep the axis the way it is. We're just going to tilt it a little bit so that it lines up with the inclined plane. So that looks like this.
You just do whatever one wants to the x-axis.
No, you can't just do whatever you want to the x-axis.
It'd be easier if I could just do it.
And you just be like, I'm going to spin it this way. All right, so here is my block on an inclined plane. If we draw the forces on this, we see that the F normal force is going to be upwards like that, and that the object is going to be sliding this way down the inclined plane. If we're looking at the normal incline or normal axis, positive x, positive y, negative y. If we did it this way, we're going to end up with some normal force at some angle and our acceleration at some angle. See how nasty that is? That means the normal force is going to have an x and a y, and our acceleration is going to have an x and a y. So that we're going to have to, basically to find our answer, we're going to have to do all these components in the x and the y, and then do the magnitude and direction formulas. So that's really nasty. To avoid that, we tilt our axis. So now our axis looks like this. Positive y, negative x, positive x. So all I did was take the axis and tilt it. So now it's a lot easier. Unfortunately, gravity still pulls straight down, so I have to break gravity into components. So what you're going to do is you're going to memorize mg sine theta and mg cosine theta. You just memorize that. That just happens. Now, the reason that we just memorize that is because if you look at it really closely, you guys remember that cosine is x and sine is y? Okay, well look at this. It's not. Sine is x here and cosine is y. The reason that is because of a geometry proof, which I could show you, but you're really not going to learn anything from it. Just memorize it. It's better. Basically, they give us this angle, and we want this angle. That's why. So just memorize it. You'll be fine. Every time with gravity, it'll work. If you have some sort of force at an angle, you'll use your normal x is cosine, y is sine. It's just that gravity for this one has to be like this.
X is sine, y is cosine.
Yep, x is going to go sine this time, and y is going to go cosine this time. Now, most of your homework problems are going to talk about inclined planes, and you don't know, is it sliding to the left, sliding to the right, which way is the incline facing? It doesn't matter. So I drew it this way. I can also draw it the other way. It doesn't matter which way you go. It's just going to change whether the negative or the answer is negative or positive. So here is another one. In case you have it going this direction, you see that it's basically the exact same thing. So this is going to be mg sine theta, mg cosine theta, Fn. And your axis, positive y, negative x, nope, that's positive x, sorry, negative x. So on the right is always positive x, on the left is always negative x, top is always positive y, bottom is always negative x. So I just took it and I tilted it that way. No flip-flopping or anything. It just stays the way it is. You're just tilting. How do you guys feel about this? You guys scared?
Pretty good so far.
Is it, did you figure out how it records your voice?
It's recording it right now. Down the inclined plane. It doesn't have to be. In these ones, because there's no other forces, it is. If it had a frictional force, it would still be going that way because friction would be kind of holding up. It could be stationary if there's a frictional force. If I was pushing it, I could push it here or pull it up the inclined plane, then it would be accelerating up that way. But as it is now, it says it's going this way. It's the only force causing it to go that way. It'll depend on what your problem says, though.
The X is just going through the box. It's not really running up the incline.
The what is?
The axis.
The axis. It is parallel to the inclined plane. Parallel and perpendicular. So X is parallel and Y is perpendicular. That's why we slanted it. So if your incline looks more like this, then your axis is going to look like this. So it follows the incline. Okay, yeah, I didn't just plop it on there willy-nilly. Okay, so here's our first example. A 10-kilogram block is sitting on an inclined plane with an angle of 55 degrees. We're going to draw a free body diagram, and then we're going to find its acceleration. So, mass, 10 kilograms. Theta, 55 degrees. Let's draw one of these things. How about this way? Doesn't matter which way you pick. I'm just going to do this. This is theta. Here's our box. Yes?
When you're finding, you add mg cosine theta and mg sine theta? You
Yeah.
add them up? Or is you do something weird with them?
We're going to do something weird with them.
Okay.
Just draw them the way you see them. Okay, it still looks just like the picture here. This is a nice basic example. Yeah, no, that's it. That's all I'm drawing for right now. I have to get to, that's this, basically.
So, instead of writing A, you're writing the mg sine theta.
The A isn't a force. The only reason I wrote the A in here is just to tell you that it's sliding down the incline.
So the curve goes back to gravity.
Yes, my gravity's been split into the X and Y. The gravity is still technically straight down. It's just with the incline, we want it to go with our axis. So we can add them up easily.
Or else it would have been.
But for this stuff, it's just draw it as you see it. Don't try to think about it too much until we get into friction, and then you can start to conceptualize it. No, this is just our first practice problem. Just write down what you see. You'll get it as you go, hopefully. What was your question? I don't know how fast it's going. I don't. We're going to find how fast it's changing, how fast it's going.
It's not.
Yes. Down the incline. Yes. In this case. Yes.
If acceleration is not a force, then where are we finding it?
We can find it even if it's not a force. F equals ma. So we're putting all the forces on here so we can find acceleration. We want to know how fast is it going to go down the incline plane, basically. But we're sort of. Because acceleration is how fast it's changing, how fast it's going. Right? It's just the question. The question is, what's the acceleration? All right. So now you have the free body diagram. Now we're going to use the math part. So here is the sum of the forces in the y direction, the sum of the forces in the x direction. Now this is asking about the block's acceleration. How's the block moving? Not down, but like down the incline, right? It's moving that way. So is it moving up and down at all off the incline plane? No. So, and is there any friction? Not on this one. There's no friction. So since there's no friction, you don't need the y side. If there's no friction, no y side. The only time that would change is if you had like an external force on it that was applied at like an angle.
Weird, like, kind of situation where...
This is the most simplest one. We'll get more complicated.
You learn why there would be no forces. It made me think, wait, just have me get at it.
All right, in the x direction, what forces are acting?
The X.
In the x direction, looking at our picture, which force is along the x direction?
G sine theta.
Mg sine theta.
Negative.
In which direction is it moving? Positive or negative? Negative. All right, this is going to be MAX. Look how there's m's on both sides. We can simplify. Take the masses off. So now basically we're left with negative times 9.8 sine 55.
Acceleration due to gravity is still negative 9.8.
It's 9.8, and our force is moving in the negative x direction.
Even though it's not falling straight down, it's on a...
It's still moving that way. Yep.
It's still 9.8.
Yes.
Will it ever not be 9.8?
And G will always be 9.8. The part that says since it's on an incline is this sine 55 tells us it's only a portion of it is causing it to go down. Okay. Yes. If I flipped it, the only thing that's going to be different is this will be positive. That's the only thing that's going to change if I went the other way. It should still be the same number. It wouldn't matter.
It's accelerating.
Yes. For this one, because there's no friction, the y is not affecting the x. In the next problem, I'll show you where it does. Okay, anybody? What? In this one they did. Not all of them. In this one they did. Okay, any more questions on this problem before I show you friction? Yes?
Does the normal force just cross out the mg cosine?
In this case, yes, they do, and we don't need it because we're only asked about the x direction. We're going to do friction, and then you'll see where it's important. All right, so now we're going to do one with friction, and now we're going to look at that y direction. It's going to be important. So I'm going to do it go in the other direction so you can see the incline this way instead. Again, it doesn't matter which way you pick. It will not matter. It will not change the numbers. So this is 60 degrees. So our mass is 14 kilograms. Our angle, 60 degrees. And it says we have a coefficient of kinetic friction, which is mu, uk, at 0.56. Don't forget that the equation for friction frictional force equals mu Fn. So now we're going to connect the x and the y side. That's why you need it. Yes.
Doesn't really use friction like static?
It'll tell you which one it's using. So this one says kinetic, the other one says static. The only difference is kinetic is moving and static is not. So if you have static friction, you know that A is going to be 0. If you have kinetic, the only time A is 0 if it's a constant velocity. But it'll tell you that in the problem. Okay, so now I'm going to draw the forces. Are we okay? Do you need me to wait?
No, you good.
Okay.
I said, how do you know which way to draw the?
Doesn't matter.
Oh, it's
It doesn't matter. Either way. All right, let's do our forces. Down the incline is mg sine theta. Into the incline is mg cosine theta. This is Fn. And if it is sliding, which way is it going to slide? Down to the right. That means that friction is going to try to slow it down in the opposite direction. And I'm just going to draw these axes on here. Yes. At least for now. Yes.
So we use friction because states as there's friction.
You'll either say there's friction or it's frictionless.
Yeah.
And if it's frictionless, it's probably going to look like this. For the most part, 90% of the time. If it says it's with friction, it'll look more like this. There are more things that we can do to it, but this is just simplest for right now. All right, does anybody need more time to catch up?
No.
Yes, okay, I will wait.
But that doesn't mean all.
So normal force is something cosine theta.
MG
MG
cosine
cosine.
theta?
It's
Yeah,
actually just
we'll
G.
see why.
So it's actually just G cosine theta. So
No,
aren't the M's always going to cancel?
No.
Not always?
No.
When are they not going to?
when you have them on both sides like this.
I can look at them on both sides. No,
See, I can find one on that side. It was just an algebra thing.
So if we're dealing with both x and y, then we can't cancel out. Even if the m's are on both sides,
If they were on both sides in every term, then yes, you can.
When are you not going to have mass on every side?
When you're talking about certain forces, like it says that the force is just 4 newtons, then you don't have a mass in that one. Okay, I hear a lot of talking, so we're going to move on. So the sum of the forces in the y direction is equal to mass times acceleration in the y direction. What's its acceleration in the y direction? In the y direction. In the y direction?
Negative.
It's 0
Negative 0.
because it's not moving. In other words, it's not elevating off the plane, right? So here's here's an inclined plane. It's slipping in the x direction, not in the y direction.
That'd be pretty wild.
A jumping duck, maybe. In the y direction, it will always be 0, unless you have like a helicopter. It'll be 0. Okay. In the y direction, what forces do we have? mg cosine theta and
Normal force.
normal force, Fn. What sign goes on mg cosine theta? Negative. And how about Fn? And it's equal to ma, but we just decided that this is 0.
We decided.
It is 0.
I don't think we came to a consensus on this one.
It's 0.
Okay.
It's always 0 in the y direction. Okay, we're going to solve for Fn. How am I going to do that? We're going to move this term over to this side. I don't know why that's so hard for people to get, but Fn equals mg cosine theta. All I did was move it over to that side. So now I can solve for Fn. Add mg cosine theta to both sides and simplify.
Wow.
While you guys write that down, I'm going to put the numbers in here. 10.
So, Ms. Phillips, why don't you go on Incline? Like, she'll be on there.
I'm going to try to post it on there. We'll see. I've tried to do it a couple of times and haven't gotten it to work.
If like the one from Friday.
It's not on there. I saved it in the wrong file.
I thought I saw it on there.
Yeah, I saw something that was like 5.31.
It's on there, but you won't be able to get to it.
Oh, okay.
Yeah. But I figured out the file that I need to save it in. So I should be able to put today's up there.
Oh, wait, right now it's now we get the friction force. This is all becoming so clear.
Why didn't you take AP? Because you're lazy?
Yeah.
All right. Okay, so we've got this normal force. We're going to take it and we're going to plug it into the frictional force up here. So frictional force equals mu Fn. Frictional force is going to be mu, which is 0.56, times this Fn that we just got, 68.6. So frictional force is going to equal 34 something. Oh, yeah. 38.
That's really a third.
Huh?
That's like a third equation. Like,
Yes.
so it's the third one.
38.4 new. What is that? Is that
Why are
new?
you so like stuck on how many equations you do?
Because I keep everything very memorized.
Yes. It depends on how you round. If you use the exact number from before, you're going to get a 5. If you round and then multiply, then you're going to get 34. Either way is fine. It's close enough. Because mine says 38.41.
So frictional force equals
It just depends on how you round. Either way is fine. You can put what you have down.
the red.
Oh, on the right, yes.
Okay. We'll do the x side now. In the x direction, what are our forces?
MG sine.
Frictional force and what was the other one?
MG sine.
Mg sine theta. What sign am I going to put on frictional force? Negative, because it's going this way. And what sign am I going to put on mg sine theta? Positive, right here, this way. It equals max. We're looking for the acceleration in the x direction, so we cannot assume that it's 0. Sorry. All right, this frictional force, 38.4. We plug it in here, negative 38.4. Plus m is 14 times 9.8 sine 60 equals 14 times ax. All I did was plug the numbers in. You don't like plugging the numbers in? It's like the easiest part. And this AX, this X just means in the X direction. It's like a big A, a little X. All right, I got 5.76. It's positive. Does that make sense?
Wait.
Yes, it's going down.
Yeah, because it's going towards the positive X. It's sliding that way. If it was negative, would that make sense?
Depends on how you drew your picture. If you're drawing yours this way, I'm drawing mine this way.
Okay, but if mine's drawn this way and I ended up with a negative number, would it make sense that it is going up the inclined plane with friction on this side? No. Friction is not going to move it up by itself. Friction is opposing motion. So if it was moving that way and our friction was that way, we knew that our friction is in the wrong spot. So check your answers, make sure they make sense. Okay, so this is our final answer. And meters per second squared.
What if you had your incline plane the other way?
Then your acceleration will be negative, but all the numbers will be the same.
Do we know if the answer can be negative or not for exposure?
Not unless it specifically says sliding to the right or some numbers to the left. But either way, you should be fine as long as you look at it. All right. Yes. Question.
Force test, the 5.76 would be the answer, right?
Yes.
Yeah, see? Alright. We're good.
All right.
I got the opposite signs.
I was going to have you guys do a practice, but we only have 3 minutes left. So here's your homework. It's 33 through 36 and 34.